What's up, everybody? Welcome back to Michael Hicks's Intro to Programming series. We're almost done with this thing. Today we're going to talk about inheritance and object-oriented programming, and this is kind of the last piece of information I want to talk to you guys about when it comes to classes. So, inheritance is basically when one class inherits data from another class. And you might be thinking, okay, that sounds cool, but why would we ever want to do something like that? And I'm glad you asked that, if you did, because we can use our contact book as an example for when inheritance would be a good idea. So let's pretend that we're still working on our contact book from our last couple of videos. Let's pretend that we still have our class called person, and now we want to add children and adults to our list. Okay, so whenever we add a child to our contact list, maybe children have specific information that we want to save on top of the name, email, birthday, and address. Maybe if you're a child, we want to store the school that this child is going to. And if we specify that the person is an adult, maybe the additional information is we want to save the workplace that this person works at. But all of these people, the person class, the child class, and the adult class, all have basic things in common. They all have a name, an email address, and a birthday. So if you imagine us making a new class called child and adult, we would have to type new variables for all of those things again. So see down here in the slide, I have an example of that. See, we have the person name, and then in the child class we have the child name, and then in the adult class we have the string adult name. But really all people have a name. So we're just typing the same variable over and over and over again. And this is very ugly and time consuming. The sign of a good programmer is a programmer who writes code that is reusable. We want to write code one time that we can use many times all throughout the code base, okay? Whenever you're typing the same variables or logic over and over again, that's a key sign that you should be using inheritance, or maybe putting this code in a function that you can call many times in different places. In this example of the contact list, every person in our contact book needs similar variables to work. Every person needs a name, birthday, and email, so we can just have the person class and the child and adult classes can inherit from the person class and automatically get these variables. So it's just a way of saving time. All children and all adults will have all of the variables and functions from our person class, and then we can add on additional variables and functions depending on what new functionality these new classes need. Now, one other thing you should know is the virtual and override keywords. And whenever we define functions, we can define a function as virtual if we want to override it later on. So think about the initialize function that we have in the person class. We can make that a virtual function called initialize, and then in our children class, the child and adult classes, we can override that initialize function and write new code that will be executed on top of the old initialize function. Okay, so it's a way of extending functions and adding functionality if we need to. And we will go ahead and add a few basic things to our contact list to demonstrate these new ideas. So let's go back to Visual Studio. And here we're going to make a couple new classes. Let's start by making a new class called Adult, just like we've done before. I'm going to call this adult.cs. And just like always, we're going to make this class public so everyone has access to it. And then here, after the adult part, we're going to add a colon and then person. And this is telling C# that adult is a person. So this is what makes our class inherit all of the data from the person class. Whenever you're working with inheritance, you want to always use the words is a. So adult is a person. Child is a person. Okay? That's how you know that the inheritance is correct, if you can say those things and it makes sense. Adult is a person, child is a person, cat is a person, nope, cat is a animal. So maybe there's an animal class that has all of the basic functionality of an animal, and then cat inherits from animal, and maybe we have dog that inherits from animal, and then pit bull, a new class, could inherit from dog, and you can keep inheriting like that. Okay? So if you come down here inside of the class, let's go ahead and make a new variable called public string workplace, because remember, whenever we're working with the adult class, we want to store the workplace that the adult works at. Let's press enter. I'd like to override that initialize function, and to do that we will use the override keyword, but remember earlier I said to override an initialize function we have to also use the virtual keyword. So let's go back to the person class, person.cs, and down here in the where it says public void initialize, let's say public virtual void initialize. And this just lets C# know that we can override this function and add additional functionality in any children class that inherit from person. So let's go back to adult.cs, and now we can say public override. And look how Visual Studio has the IntelliSense come up, and we see this initialize function is a choice we can pick. Whenever Visual Studio autofills this out for us, it automatically puts this line of code, base.initialize. And what this is doing is this calls the initialize function in the class below us. Okay, so base.initialize will call the initialize function on the person class. So all of the code that is inside of initialize in the person class, see here it says private example equals false, name equals new person, birthday equals date time today. All of this will be executed, and then we can add additional lines of code underneath that if we want to initialize other things that are unique to the adult. So I'm going to say workplace equals Michael Arts Studios because that's where I work, and we'll have all of the stuff initialized in the person class, and we'll initialize the workplace with a default value. Let's go ahead and overwrite the name as well. So remember, in the person class we set the default name to new person. If we're an adult, let's say the name is new adult, and that will help us out later when we add adults and children and people, normal persons, to our list. We can have the default name be different things so we can see which one is the adult, which one is the child, and so on. Now, if you guys remember in the last video, I talked about different access modifiers. We learned about public and private, but remember I also said there was one called protected. And protected is just like private. You can only access protected members inside of the class you're working in. But the difference between private and protected is that if your variable is protected, the inheriting classes can also have access to that variable. So if we go back to person, and underneath the private bool, private example, I'm going to write protected bool, protected example. And if we go back to the adult.cs class and in initialize here, I'm going to try and access the private example bool, and note how it doesn't even come up at all. We have no access to that because it's private. However, I do have access to the protected example because adult is inheriting from person. So I'm going to set that to true. Let's go ahead and make the child class that we talked about earlier. Add class, and let's call it child.cs. Hit add. And this will be very similar to the adult class. Let's go ahead and make this a public class. And let's make it inherit from person. And then underneath down here, let's make a public string called school. And this will store the school that the child goes to. Let's override the initialize function. And after we call base.initialize and initialize all of the stuff from our parent class, let's make our school set to Forest High. I'm just making that up. And our name can be new child. Alright. Now our classes are basically done, but there's one other thing. If you remember from the last video, we worked on adding XML support to our program. We made the program save and load XML files. And whenever you serialize XML files, you have to have a default constructor in your class so XML can properly serialize the data. So if you notice, in both of our new classes, we have not added default constructors. So let's just make an empty constructor in both of these classes so the XML will work later on. We'll call this public child. It'll just be empty. And here in the adult, we'll say public adult. So now that we have the adult and child class that inherits from person, we need to actually have a way to add these into our contact list. So let's go back to form1.cs and go to our add button click function. And here we are adding a person whenever we click the add button. But let's say if you hold down the shift button and click add, you'll add an adult. And if you hold down the control button and click add, you'll add a child. And if you have no buttons held down, you just add a normal person like before. So to do that, we can say if modifier keys dot has flag keys dot shift equals true. We will add the adult. And the modifier keys variable, this is basically where C# holds if the shift, control, and alt keys are being pressed down. The modifier keys are shift, control, and alt because typically in programs, when you're holding those down, you're trying to modify something. And if has flag is true for whatever key we're asking about, that means that button is being held down currently. Alright? It's pretty straightforward. I'm going to copy and paste this and put an else in front. Else if modifier keys dot control is held down, we will add a child. And finally, else if neither of those are held down, we'll just add a person like normal. Let's press F5 and try to add these new classes to our list. Alright, here's the people we saved from the last video. I'm going to hold down left shift and press new, and there's a new adult. I'm going to hold left control and hit new. There's a new child, and I'm going to press new normally, and there's a new person. So we have 3 different types of classes. They are all people, so they belong in our list, but there's different types of people now. We have an adult and a child. Now, it would be cool to at least see a little bit of the custom information shown on the right side. I don't want to go full on and add a text box and everything because I want this to be a kind of quick video. So let's just add a label underneath the notes part here that tells us what the current school or workplace is set to, depending on if we're an adult or a child. I'm going to exit out and go back to the Form 1 design view. Let's go to the toolbox, and I'm going to find a label. Double click. I'll put it here. And let's name this label Adult Child Label. That way we have easy access to it in code. And I'm going to set the text of this to nothing. And whenever you do something like this, if you need to find this label, it'll be hard to click on it when it says nothing, but you can always find it from this properties drop-down menu here. See, here it is at the top, adult child label. Alright, let's go back to form1.cs and let's go to the listBoxChanged function. And at the very bottom, after we set all of this core basic information, we'll say if person is adult, adult child label.text equals this adult works at person as adult workplace. So the is keyword is basically just checking to see if this person is an adult. If this person is an adult, we will change the text of this label to say this adult works at whatever this is set to, which we manually set it to Michael Art Studios. Else, if the person is a child, similar thing here, we'll say label equals this child goes to school at person as child school. And notice we have to cast the person up into whatever class it currently is to get access to the custom variables that it has, right? So, you know, an adult or a normal person doesn't have a school variable, only the child does. So when we do this person as child, that is casting it or converting it into the child class. And finally, else, if we're not the adult or the child, we'll just set the text to nothing. Okay, let's press F5 and see if this works. I'm going to hold left control. We have a new child here, and this child goes to school at Forest High. I'm going to press left shift, press new. This adult works at Michael Art Studios, and when I press new for new person, we get nothing. See, we can toggle between all of these, and we see the custom information depending on the type of person in the list. Now, one thing that I saved for now is if you press save, we get a crash. And here is that nice little error message that we programmed in the last video that says exactly what the problem is. Error saving the contact list. There was an error generating the XML document. The type addressbook.child was not expected. Use the XML include or SOAP include attribute to specify types that are not known statically. Now, what this means is that we are trying to save a list of people, okay? And yes, all adults and all children are people, but XML isn't sure what specific information is stored within those classes, right? All it knows about is we're serializing a person class. It doesn't know about the data that's inside of the children and adult classes. So, if we go to our savefile.cs file, we can add a element right above this list that lets XML know, hey, these classes inherit from person, and you need to look up the data within them to accurately save out this list of people. Okay? And to get access to this XML attribute that we need to use, we need to actually include using system XML serialization at the top. And then down here, you need to have a bracket like this, and we will say XML element, parentheses, quotation, adult, type equals type of adult. Okay? And make sure that whatever you put here is the exact spelling of the class that we're trying to include here. And basically this just says, hey, XML, this adult class is a type of adult. Please include this in the person list. Okay? Let's also add a one more for child. I'm just going to copy and paste here. Child equals type of child. And now, since we're specifically specifying what needs to be included in this list, we also need to have an XML element for person as well. Otherwise it will crash like last time. So person is a type of person. Cool. Alright, we can press F5 now and see if this works. I'm going to add a new adult called Michael Hicks. I'm going to add a new child called Michael Hicks Jr. Oh, I forgot to say, my bad. Oh, okay, it's working. New adult, Michael Hicks. And finally, a new person called normal person. Okay. Alright, and it looks like everything is saved. It's not crashing anymore. I'm going to exit out and then restart the program. Michael Hicks Jr., Michael Hicks, and normal person are all 0 years old. And look, it's definitely being loaded in to the right class, because here it says the adult works at Michael Art Studio, the child goes to Forest High, and this normal person has no special info. And that's it for this video, guys. I hope this was a good introduction into inheritance, and I hope you see why it's useful. We'll be using this a lot more in future videos where we do more game-specific programming. So you'll definitely see inheritance used a lot more in the future. I hope you guys enjoyed the video, and I'll see you on the next episode.